The diagram below shows trolley A of mass 2 kg traveling at a velocity of v meters per second east on a straight horizontal surface, colliding head-on with trolley B of mass 4 kg traveling at a velocity of 5 meters per second west. And then after the collision, the two trolleys stick together and move at a constant velocity of 1.67 meters per second west. The collision only lasted for 0.01 second. Ignore the effects of friction. And then 4.1 says, state the principle of conservation of linear momentum inwards. We know fully well that it says that the total linear momentum in an isolated system is conserved. The total linear momentum in an isolated system is conserved. What does that mean? The sum of the momentum before a collision will be equals to the sum of the momentum after the collision. And then 4.2 says, let's calculate the magnitude of the velocity v of the trolley A before it collided with trolley B. The magnitude of the velocity of trolley A before it collided with trolley B. In 4.1, we stated the principle of conservation of linear momentum inwards. And then in 4.2.1, we're going to use that definition to determine the velocity v of trolley A. So what does the definition essentially say? We've went through that, right? We're saying that the sum of the momentum before will be equals to the sum of the momentum after. Before the collision, we have the 2 kg trolley moving towards the east and the 4 kg trolley moving towards the west. So what we can do here, we can take one direction as positive, right? It only makes sense to take east as positive. Let's not forget that momentum is given by the momentum is equals to the mass multiplied by the velocity, right? So the momentum of the 2 kg trolley will be the mass of the 2 kg trolley multiplied by the velocity v, right? Plus the momentum of the 4 kg trolley. It will be the mass of that trolley multiplied by the velocity it possesses, right? And this will be equals to, we are told that after the collision they move together, right? They become one body, so we can add up the masses. So we have the mass of A plus the mass of B multiplied by VF that they move with together, right? So what is the mass of trolley A? The mass of trolley A is 2 kg. And then what is the velocity of trolley A before the collision? That's what we don't know and we're looking for it, right? So we just have V plus the mass of trolley B, which is 4 kg. And then what is the velocity of that trolley? Is 5 meters per second, right? To the west, we must put a negative sign, right? And then this will be equals to, we're summing up their masses. So we have 2 kgs plus 4 kgs. And the velocity after, which velocity do they move with? 1.67 meters to the west, right? So if it's to the west, then we must put a negative sign. Minus 1.67, right? And then now the physics is essentially done and we're just solving the math, right? We're looking for v. So 2 multiplied by v, that will be 2v, and then 4 multiplied by minus 5, that will be minus 20, and that will be equals to essentially 6 multiplied by minus 1.67, which is equals to minus 10.02. So now 2v will be equals to minus 10.02 plus 20, right? So v will be equals to minus 10.02 plus 20, everything divided by 2. And the answer is 4.99 meters per second. We know that positive is to the east, right? So we can write here and say to the east. If the value was negative, then we would know that that velocity is to the left. And now we can do 4.2. 4.2.2 says, let's calculate the force that trolley B exerts on trolley A, right? the force that B exerts on trolley A. Since this question is on momentum and impulse, let's use Newton's second law in terms of momentum, right? We know fully well that it states that F net is equals to the rate of change in momentum. So if we can calculate the rate of change in momentum of trolley A, then we will know the force that B exerts on A. So what is the change? We know that delta P is equals to momentum final minus momentum initial, right? So F of B on A will be equals to the change in the momentum of our trolley A, right? So the change in momentum, we're gonna have the mass which is 2 kg, right, multiplied by the velocity final. The velocity final is this 1.67 meters per second that they move with after they've joined each other, right? So we're gonna have, and that velocity is to the left, so let's put a minus sign when you substitute it, because we take in east as positive, right? So we're gonna have minus 1.67 and then minus the momentum initial, right? So we have 2 kg again multiplied by the velocity initial. We just calculated it here, right? Is 4.99. So we have multiplied by 4.99, and then we divide everything by the time the collision takes, right? The collision lasted for 0.01 second. So everything divided by 0.01. And then the answer I'm getting here is minus 1,332 newtons. We've already established that the direction to the east is positive, right? So since we have a negative value, then we know that that force is exerted to the west, right? So we're gonna have 1,332 newtons to the west, right? And it makes sense. If trolley B is moving to the west and then trolley A is moving to the east, then when they collide, trolley B will exert a force on trolley A to the west.